Hi, welcome to How to Repair. Is your washer dryer not drying the clothes? Are they coming out soaking wet? This video is going to show you how washer dryers work and how to rectify the most common problems. For ease of filming today, I'm going to be working on an integrated washer dryer. This is because the whole cabinet comes apart, so I can easily show you how the machine works. Whether you have a freestanding washer dryer or an integrated washer dryer, the process of the drying system is exactly the same. Okay, I'm bringing up an exploded diagram to assist you in understanding how the basic system works before we start stripping down the machine to look at common problems. We have a heating system at the top of the machine which is driven by a fan motor. This blows the warm air through a ducting system at the top into the top of the door seal and it enters the drum. This then starts evaporating the water that's in the clothing. This warm moist air then goes through to a condensing unit at the back of the machine. On the condensing unit you have a water valve that trickles a small amount of water down the condensing plate. The warm moist air settles against this plate and collects. It then trickles down to the bottom of the machine to the sump hose, and then the pump extracts the water out of the machine. And the process will continue doing this for the required drying process. We also have sensors. Some have thermostats and some have NTC sensors that control when the heating system comes on and off. Some machines even have moisture sensors to automatically detect when the clothing is dry to turn the machine off at the required point of dryness. This therefore saves money on electricity. And you can hear the pump system come on now, and this is extracting the water out of the machine. Now let's take the machine off the workbench and have a look at each individual component. Okay, the first thing we need to do is take the cabinet apart. Now let me quickly explain. If you have a freestanding washer dryer, some of these are highly complicated to get into the working components. You may even have to take the drum out of the machine. Other machines are easy to work on, like this one, and we are able to remove the top and the whole of the back of the machine to give clear visibility to each working component. Do always keep your screws in order of the way you took them out, as some screws have different threads. I'm also going to take the water valve protection unit at the back here off so you can visibly see all the components. Okay, now we've got the back off the machine and I can show you the whole machine. I'm going to quickly talk you through each individual component before we do a live test on this machine to show it you working. Now I've had to support the water valves with a cable tie and also the electrical filter or suppressor because they attach to the back plate, and I needed to make sure that they're safe and there was no electrical problems when testing the machine. Now, on all washer dryers you have basically 5 components that are exactly the same on any individual machine on the market today. Apart from heat pump technology, that is a different drying process. That's basically a dehumidifier, and they're starting to produce washer dryers now with dehumidifier systems built in. But on the conventional washer dryer, you have the heating system, the fan motor or blower, the condensing unit, a pump at the bottom of the machine, and an individual water valve which is designated to trickle water down to the condenser. So we'll start with the water valves. There are 3 water valves on this machine. 2 of them are used for the wash cycle. In other words, the pre-wash, main wash, rinse program, and then both of the water valves combined together will actually send water to the conditioner department. The other water valve is a low pressure water valve that basically only allows a trickle of water down this pipe to the condenser. This cold water coming down the condenser creates an area where the warm, humid air coming from the machine will condense, then the water will trickle down to the pump and be extracted from the machine. We also have multiple sensors on the machine, but I'm going to start with the airflow. When the machine is turning, the basic blower or fan motor will come on, drawing air from the bottom of the machine up through the heating system. Now the heating systems will vary from machine to machine, and you may have a single element or, like this machine, a dual element, and I believe the total wattage of this element is somewhere in the region of 1800 watts. This then goes through the heating box at the top, but it also has a safety cutout thermostat on the side. And if you have a Bosch, Neff or Siemens, just to let you know in the future, if you do have an overheating problem with your dryer, these thermostats are resettable. When they go open circuit, they disconnect the electricity to the heating system. When they're working, they're closed circuit. So there is a little button on the side. The warm air then travels through this box down into the drum via the door seal. But it also passes over an NTC sensor, which you can see on the screen here. This NTC sensor measures the air temperature going into the machine. The air then goes through the machine, evaporating water off the clothing as the drum is turning. This warm, moist air is then drawn in through the bottom of the condenser, also going over an additional NTC sensor. There are 3 NTC sensors on this machine, one at the top, as I said, one on the heating circuit, which is only for the wash cycle, and another NTC sensor slightly higher up, which is measuring the air temperature. Now, I can't tell you the values of these NTC sensors. I will measure them for you later, but my problem being is Bosch is one of those companies that is very poor at supplying technical information to the general public and other engineers. Anyway, this warm, moist air comes up the condenser and starts to settle on the condensing plate that's cold. This water turns into droplets, drains down to the bottom of the machine, and then empties via the pump. This air then is reheated as it's drawn into the heating system, and this continues for as long as the cycle needs to go on. On some washer dryers, you do have moisture sensors on the machine which will detect when the clothing is dry and then turn the machine off, not to waste energy. There are many different thermostatic systems depending on the manufacturer that you have, but the basic principles of the washer dryer is that. Now, on some machines, you even have maintenance programs. Now, for example, this machine has a maintenance program which clears the fluff. Now, if you're lucky enough to have a fluff cleaning program or something similar to that, depending on what make you have, this is manufactured by the Bosch, Neff and Siemens group. And you can hear the fan motor on the heating unit running. And the water spins fast to chuck water up to that area, and this will hit the fan blade that's turning and clean all the fluff off the system. It is well worth doing this quite often. The reason being is if you don't do it, the fluff that gets up there can dry and become very hard. Then it becomes difficult for the machine to clean the fluff off the actual fan blades and in the ducting unit. From this unit here, in other words, the motor and the fan blade that gets fluff building up on it, and also cleans inside this box. Okay, I just want to quickly go through some of the most common faults before we go into testing the machine. If the heating circuit, an NTC sensor or the cutout thermostat is faulty, or it may be even a faulty circuit board, therefore the machine would not be drying the clothes. What you'll end up with is clothes that are wet, damp, but not warm inside the drum at the end of the cycle. If the fan motor is unable to blow the air through the system, either due to a blockage in the heater box, a blockage on the fan blade, or blockages in the condensing unit, what you'll end up with here is clothes that are taking a long time to dry, maybe twice as long as it used to when you first bought the machine. And lastly, if the condensing process is not able to take place, you may have a faulty water valve, blockages in the condenser. What will happen here is the machine will end up at the end of the cycle with damp, warm, wet clothes. Now, what we're going to do now for you is have a look at some different heating boxes. And we have one here from Samsung. This has got the fan motor, the heating element, which is a single heating element, a couple of thermostats, and an NTC sensor. There would be other sensors on the machine as well. Now we have a hot point box, and this box is aluminium, and it's got single heater, again, fan motor on the top, and the heating unit with an NTC sensor. And there would be additional NTC sensors throughout the machine. But I'm quickly going to take this apart for you so you can see. Now if you look closely inside this heating unit, we have the heating element here, and you can see there's bits of fluff in here but nothing really bad. But if we have a look at the fan blade here, and this is where it does get bad, and if I bring it up to the camera for you, if you look here, and I'm going to go over each blade, you can see the amount of fluff that I'm taking off the fan blade. And this inhibits the airflow going through the machine. If the motor is not turning at the correct RPM, and I've only done a couple of blades there, and you can see the amount of fluff, this all prevents the machine from working efficiently. Okay, we're now ready to test the machine, but I wanted to give you some visual aids to understand what's going on. This machine actually does have a fault that we're going to rectify while we actually test the machine. Now, I've put this twin temperature gauge system on here for you to see. One of the temperature probes are attached to the door glass on the door, and this is reading at 30 degrees at the moment. This is going to measure the temperature coming from the heater where the ducting comes through the door seal and the air blows onto the door glass. The other probe here, which is channel 1, which is the top one, and I put my fingers on it, it goes up to 32 degrees. And now it'll drop. We're going to attach here on the condensing unit. This is going to do two things. Firstly, we will be able to see the temperature coming out of the dryer. So as the warm moist air travels up through here, we'll see the temperature. But we'll also see what happens when the water valve kicks in and trickles water down this tube. You will see a large differential in temperature, and this is where the water condensates. Okay, the door glass is 32 degrees and the back sensor is 26 degrees. I've set the program to intensive and I'm pressing start. These washer dryers will go through a sequence of different spins and everything while it detects the amount of water in the machine, and it will vary from model to model. You can also see up here that the heater has kicked in and we can see that the fan motor is turning. At the moment we're drawing 1800 watts of power, and we have an air temperature of 34 on the door glass and 27 on the back sensor. These temperatures will start rising now as the air goes through the system. We are not seeing any water trickle down the condensing tube here. This may come on in a few minutes. Some machines will come on immediately, other machines will come on after a few minutes. And the machine may even do a spin depending on which model you have, as it detects moisture in the clothing, which it's able to decide that it's able to get rid of that water by increasing a spin speed. So we're still seeing 1800 watts and we're starting to see the temperatures climb. The door glass now is 40 degrees and the back is 30 degrees. I just heard the pump come on and the machine will go through the cycle. Now I'm going to skip forward to the appropriate places to assist you, so you don't have to sit here for 1 hour and 40 minutes or 2 hours, whatever the drying side is. But within this short space of time, we have got up to 42 degrees and 32 degrees. I'll put the camera back on once we get to the right temperatures. Okay, the machine has been running for 5 minutes. It did do a small spin. We can now see that the temperature on the door glass is 60 degrees and the temperature at the back here is 40 degrees. But what I have not seen is any water coming down this tube at all. And I'm suspecting that we have a water valve problem. We'll give it another 5 minutes, but if I don't see any water coming down this tube, I'm going to stop the machine and then test the water valves. Okay, we're nearly at 70 degrees and the machine has been running approximately 10 minutes. The pump has been coming on and off as required, but I have seen no water coming down here at all. And at the temperature at the back at the moment is 48 degrees and the temperature on the door glass is 70 degrees. So I'm going to stop the machine now so we can test the water valves, because we should have water coming down this tube by now. Just pressing the pause button. stopping the machine, and I'm opening the door, and the probe came off when I opened the door, but that's not important. And now I'm going to disconnect the power, and we're going to test the water valves. Okay, we're ready to test the 3 water valves because I'm not too sure which one it is. I think it's this one, but I just wanted to explain the difference on the connectors. Some water valves have spade connectors, other water valves have, and I don't want to put that on the heater, and other water valves have a special plug that goes into them. Depending on what make of machine you've got, I've actually got a test plug here where I have the test plug attached to the meter, and I've set it onto continuity in an ohms reading, and I'm going to take out each plug one at a time and test for the resistance. Just bear with me 1 second while I turn the meter on and plug that in. This water valve has got a reading of 1.738, and that is perfect. We'll plug that wire back in. We know that water valve's good. The second water valve, take the connector out, put the plug in, exactly the same reading. The coils will all be the same values. They very rarely ever differ at all. So we'll put the brown one back in. We've taken out the back one here now. Plugging that in, and as you can see, this water valve is open circuit. This means that no water was able to pass down to the condenser, meaning it was unable to condense properly. That means that it was taking a long time to dry the clothes. Other faults that you may be getting are a lot of steam in the drum, but the water does not disappear and the clothes are just warm and moist at the end of the drying cycle. They haven't dried sufficiently. So what we're quickly going to do now is replace this water valve. Because I didn't have a genuine part, I've managed to swap the coil out on the end of the water valve. I will show you how to do that in another video, but I'm just showing you the difference between the two. This is the new water valve. The locking mechanism is on the other side, but it's exactly the same. And now we have a reading. And this is a little bit trickier to get out. But if I put that on the original coil, it's open circuit. You can measure the coils quite easily using the probes as well. But you have to actually go down in the actual slot and get these onto the 2 original contacts. And they are quite tricky to do, but even doing it that way, I can see that it's open circuit. Nothing at all. So reconnect all this up and we're ready to test the machine again. Okay, plugging the machine back in, turning it on. Make sure the water valve's on because I just turned it off to replace the valve. Shut the door and press the drying cycle again. And as you can see, our door temperature is 32 degrees and our back sensor is 25 degrees. And we'll let the cycle go through again, and I'll start the camera again once we've got up to temperature. But as you can see, when we first start the machine, there's no water coming through here yet. It should be coming through once it gets to temperature. Okay, we've now seen that the machine has been running, and if you look closely in this tube here, you can see water actually in the tube that's trickling down to the condenser. And we have a differential between 82 degrees on the door and 47 degrees on the back condenser. And if you just look here closely, and I'll zoom in for you in a second, you can actually see the water in the condenser here now. And this is trickling down, keeping the condenser slightly colder, causing the differential between the 2 plates, and therefore the humidity settles against this area. Now the machine has been running for about half an hour now, and we've got up to temperature. You can actually see water in this pipe. If I tap it, you can see the bubbles coming across, and it is a very small trickle going down. The differential in temperature, we have approximately 57 degrees on the back plate here, and the air entering the machine is 93 degrees. The differential between the two is causing the condensing process of the vapor to collect along this area. And I just want to quickly show you, and you shouldn't do this with the machine running, but if I just take this pipe off carefully, and I can show you how little the amount of water that's actually coming through here. This is a very small amount of water that trickles down the machine, and the water valve will come on and off as required while it's doing the condensing process. A little bit more, it's just turned the valve on again. And it is a small amount of water coming through here. And there we go, the machine's up and running. You do notice here that we're only pulling just under 1000 watts at the moment. That's because the heating system will change between full heat and half heat as it needs to maintain the temperature inside the machine. And over the door glass we've got a temperature of 90 degrees. Remember, this is on full heat. You can actually select a lower temperature if required. And on the condenser at the back here we have a temperature of 59 degrees. And water now is flowing through this pipe, causing the condensing process. The pump turns on and empties the water from the machine every few minutes or so. There's a previous video on how to replace the carbon brushes on this motor system, as that was also a fault on this machine, and I will do another video for you with regards how to replace the water valve system. I didn't do it in this video because it was a little bit longer process and I didn't want the video to drag on. Please remember to like and subscribe to the channel, as that's what keeps us going. And if you do need any spare parts for any of your washer dryers, there's a link in the description that will take you through to the web page, and I'll be happy to help you with any problems that you may have. Thanks very much indeed for watching. I hope you enjoyed the video.